Chapter 16, Part 1 and Part 2, Worksheet. Alright, so as you may notice, it's very similar to correlation as far as the first few steps go. You're going to fill out this table using the given x values, which will be the first variable, in this case TV hours, and the given y variable, which in this case is axis of regression, and you plot them here. You then get the mean of these 4 x variables and 4 y variables. The mean of x equals 10. The mean of y equals 6. You then take all the deviations from the mean and you square the deviations from the mean and you get SSX. You do the same steps for y. You have a mean of 6. You're going to get the deviations from the mean, which is this row right here, y minus my. Then you square them, add them up, and now you have SSY. The last step is SDP, the sum of the deviation products. You take each deviation score, which is x minus m before you square it, and y minus m before you square it, and you multiply them by each other. So if you look at the first one, that's 4 times 3 equals 12. You do that for all 4 participants. You add them up. You get a SDP of 36. All right, this is the same first step that you will do when also doing correlation, if it looks familiar. Next, we're going to solve for B, which is the slope. You'd simply take SDP and divide it by SSX. 36 divided by 40 equals 0.9. Next step, solve for A, also known as the intercept. That formula is the mean of y minus parentheses B times the mean of x. So in this case, it's going to be 6, because 6 is the mean of y, minus, make sure you put the parentheses, 0.9 times 10, which is the mean of x. Calculate that, you'll have the intercept of minus 3. Now you have to write the linear prediction rule, also known as the equation of a line, or the equation that we will predict x from, well, we will predict y from a given x. Hence why the x is right there, because then you will take an x and insert it into this formula. So y hat, which is this y with this little hat over it, means predicted y. So in this case, you're going to take y equals bx minus 3. So the formula is y equals bx plus a, but our a, also known as our intercept, was a negative 3. So when a negative and positive are next to each other, it turns negative. So another way to look at it is whatever you get for a, whether it's negative or positive, goes after you put bx. So in this case, it's 0.9x minus 3. Now you have your prediction formula. Next question asks, just to predict what y would be if x was 5. So the way you do that is you just plug in 5 for x. You do 0.9 times 5 minus 3. That equals 1.5. So we are predicting that if we had an x of 5, we would get a y of 1.5. And if you look at it in the terms of the question, if a child watched 5 violent TV hours, they would have 1.5 acts of aggression. Okay. The next step is you are going to fill in the table below to figure the SS error. Okay? So what you do there is you plot the original x's, the original y's, and now you have 3 new columns you haven't seen before, which is a column of y hat, y minus y hat, and y minus y hat squared. eventually giving us SS error. So to compute these y hats, you take the original x and insert it into the formula that we got here. So you do that for each x value, and you will get these y hat numbers. Now, once you get these y hat numbers, you're going to take the original y minus y hat. So you do that for each participant, and then you square them. So once you square them, you add them up, and now you have SS error equals 5.6. Okay, now we're going to use SS error to eventually compute r squared and r. So the way we do that is we take SSY, the original SSY from above, minus SS error divided by SSY, which is 38 minus 5.6 divided by 38, which gives you an r squared of 0.85. Now, how do we get r from r squared? We just take the square root of r squared, which is 0.92. All right, so I want everyone to take a look at, let's say this SS error equals 0. The only way this SS error could equal 0 is if all our predicted y's were exactly what our original y's were. So we know that that's not there, so we know that this is the SS error of this. So if we did have an SS error of 0, that would mean that our predicted y's are exactly what our original y's were. So we would have, then we would have an r, or a correlation of 1. And when looking at regression while using this technique, the 1 would represent we have a 100% chance that we will predict the correct outcome. So in this case, a r of 0.92, you could also look at it as there's a 92% chance that we will get the correct prediction from our regression equation.